Yeah, I guess we're basically ready when you are. We have, I think, 14, 15, 16 people other than us. Again, I
Sure.
think that number is growing. So feel free to just get started whenever you want to.
Yeah, let
Um,
me just try to
I think
fix
Mr.
this here.
Karthik can confirm if the live stream has actually started or
Yes, I just started the live.
you can start it. Okay, so it's say maybe please go ahead and
Yeah, I guess we're basically ready when.
I okay. Uh, I'm just making sure people can hear me because the audio seemed to cut off.
Yeah, I think I had the YouTube stream playing in the background, so I just muted abruptly.
Oh,
Your
okay.
voice.
So got it. Also, I'm trying to
Um,
get the access the WebEx interface, but I just see
yeah, I think now it's gone and we just see your presentation screen. So
right, but I don't see the panel where I can actually look at the chat or do anything. So I'm not sure whether that's by design or like.
the screen or something? Um,
Yeah, no, just the full panel where you can join and all
oh,
that happens.
oh, I see. Okay.
So I'm not really sure what's the best way to get that, but sure, we can get started, I suppose.
Yeah, I guess I will track the chat and maybe
Yeah,
keep in touch with you over
sure,
um,
sure.
Discord, I guess. Discord DM. Yeah, cool. Sounds good. I think Karan says that you're audible, so we're good to go.
Okay. The lighting is a little annoying, I must say. All right, so hi everyone. I'm Shashank, and with Professor Neeldhara, we're very happy to be getting started with this course, CS Research 101. The course website, I think, should be accessible to everyone. And let's see, we probably have 14, 15, 16, 17 of you. It'll be great if you could turn your videos on so that we can actually run this like a little course where we get to see you, you get to see us. We actually have like an interaction. Otherwise, it's not really much fun for me to be talking to a screen and just going through these slides. So yeah, it'll be fantastic if you could turn your videos on, sort of also interact. We strongly encourage interaction because at the end of the day, we really want this to be like a discussion which you folks are involved in, get your thoughts, and yeah, really, this is for you. So you need to be the key players in this entire dialogue. All right, so let's see. Let's start off by just giving you a little bit of like a little bit of context and some introduce set the origin story up for as to why we are starting off with this course. I am a PhD student in computer science, and I will probably be graduating soon, sometime next year. And I'd reached out to Neil, probably.
Hello, sir.
Sorry.
Yes,
Yeah.
that WebEx notification was hiding your screen. So can you close that?
Wait, no. The WebEx notification is hiding my screen. That's very odd.
So there is a little bit of a panel with
Yeah,
just
panel in the front of the screen.
there's a small
Oh, so
UI.
that's okay. Okay, that's the panel I was looking for. All right, fantastic. Okay,
Yeah.
so this panel is here. Got it. So things should be clear now. Let me
Yes,
just
I
make
think
sure.
we can go. Yeah, thanks.
Okay, so great. So yeah, as we're saying, the origin story is yeah. I'm like I'd reached out to Neil probably like a year and a half ago when she had prepared some material herself where she was introducing sort of like how to navigate a PhD program when you get into your PhD in computer science. How do you think about this? What does it entail? What's the right way to? So what are some things to look out for and so on? And around the same time, I had also written up like an article on or like a post on my webpage, which pretty much addressed this question of like how do undergraduates start off with research because to set some more context, I spent like before joining grad school, before joining my PhD, I spent close to 6 years working in a corporate research group. And after coming into grad school and starting off my PhD, what I would see invariably was irrespective of like where students have done their or like how strong their undergraduate degree was, they would still come and just absolutely have a hard time in their PhDs simply because they would there would be like a general sense of being lost or not really sure of like how to navigate the process and like yeah it would not be as enjoyable as I would have hoped for others as well because I thoroughly enjoyed it. I am enjoying it and but I would see this pattern come up over and again as to people not really enjoying it and that is one part and the other part is of course having been through the undergraduate system myself I knew and I still know that probably research is not a component that is emphasized at the undergraduate level at all even now and probably it is in the like probably 5 or like 10 schools or 10 institutes or colleges in India but if you go away from them then you absolutely have like no formal introduction to research so this was worrying and that's why I think we got in touch and we were like okay since we I think there's like a common problem that needs to be addressed and hopefully we can influence the future sort of batches of students who come up to be slightly more aware of what this process entails and what to really expect because mostly people have just like a romantic notion of research even until after having applied to like a let's say like a PhD program where they would actually be doing full-time research and then come up and face like harsh realities after having gotten in. So we wanted to make sure that yeah people don't go through that or like hopefully can avoid that loop and if possible and yeah just set this information out in a more systematic way. The problem is like there are all these blogs and resources that people keep putting up in a one-off sort of fashion and the larger yeah aim was to sort of consolidate all of them and just explain that and like put that make that slightly more structured and inculcate that in, I mean like convey that information in a slightly organized fashion. So that's the origin story to this entire course. And yeah, we really hope that this is effective in like getting you to introspect what research is all about and like actually get you to consider research as an option and just provide more information. So things that you would have probably learned after having gotten into like a full-time research role, be it like a PhD or like a, let's say, research job or anything of that sort things that you would have probably learned then. The idea is to sort of fast track that information and actually get some sense before you get into all this. So that's some context. What we'll do is let's start off by actually spending like 5, 7 minutes or 10 minutes going through this little survey that probably most of you would have received. If someone's not received, you could let us know in chat and we'll drop this link over there or probably I think an announcement went out on Discord as well. So you should have access to this link. So please go ahead and do respond to it. Use these 5, 7 minutes for you to actually think about these questions as well. And of course, through the course of this entire course, we will tie it back and we'll see why these questions are probably relevant or irrelevant and set some context to it as well. So let us know if you have any questions. Let us know if you have any clarifications. Feel free to yeah raise them, speak out, or like chat. Anything is fine. But yeah, just go ahead and if someone's having an issue accessing the link, just let us know and we'll make sure to hand you out that link. For those of you who joined in late, the request there is to please turn your cameras on so that I actually get to see you. We all get to see you. We all get to see each other. That way, this is slightly a much more interactive session. It actually feels like a classroom, and we can yeah get to know each other much better than yeah just me staring at a blank sort of grid of names. So when people are done, you could just probably drop in the chat that you're done. I'm also monitoring it, so I'll also get a sense for like how many responses are in. I know you can just see half my face, and I'm trying my best to sort of do something about this. It's like bright and sunny outside for a change today, and unfortunately, I've got my mirror, I like my shade setting all wrong. So let me try to fix that in the meanwhile. I think people are trickling in. So if you've joined in, this is not some meditation session. People have been sent out like a link, and people are just filling in a form. So the unusual silence is because of that. So if you know what link we're talking about, go ahead and fill in the form. Else, just mention this on the chat, and we'll be happy to forward the link to you. I'm quite saddened by the fact that someone has put pizza as their favorite food. So yeah, we'll be talking about that as well.
Sir, could you please resend the link?
Yeah, sure. Let me see what's the best way to do that.
Sorry. So, Varun, I think you should have it now from the chat.
Yes, ma'am, I received it.
So I guess most have answered. I see around like 20 responses, so we could probably just go ahead and discuss the responses. So let's, yeah, okay, we've got like 26, 27 responses. I think that's sufficient. And if someone's like going through it, as long as you've understood the questions and like thought about the questions a little, that should be sufficient to get started. All right, so let's see what folks have actually responded, and then let's all get a sense for what the responses are, and we'll use this information. We'll come back to it at different points in this course, but I think it's useful to know how your friends think about these questions and how you've thought about these questions. Of course, all these responses are anonymized, so these are all just aggregate statistics. I believe and I hope the responses are visible to you on the screen. Is that a yes? Could someone just like give me like a thumbs up if the okay, all right, thank you. All right, so as the responses are trickling in, let's quickly try to like go through what most people have said. So yeah, favorite food. Oh, it's all over the spectrum. I see. The winners are dosa, bisi bere baat, which is something that I didn't expect, and biryani, of course. And that's who your friends are in this particular like cohort. So you've got like a wide range to actually enjoy. All right, so lots of people have mentioned machine learning and AI, unfortunately, as like their favorite course. Unfortunately, I say this unfortunately because I also work in this, but it's become so much of a hype that yeah, everyone wants to say ML and AI, and it's the cool, snazziest thing. Algorithms is 60%. That's pretty cool. That's probably, again, because of competitive programming and the most exposure to one of these courses. I see 10 people say compilers going strong. Theory of computation, programming. Yeah, that's good. So there's like a whole spectrum over here. Science, computing, data science, cryptography, blockchain, physics, data science. Yeah. So this was a disclaimer I should have probably mentioned, which you also asked me to mention. If this was not relevant to you, this is like a mixed group over here. I'll mostly be communicating in English because that's the language which will probably get across to most of you. And also, I believe it's a CS heavy audience, but if you're not from CS, don't get put off by these some CS specific questions and options. You could just answer it in your context. So that's totally fine. It's just these questions are more to get you to think rather than like for us to do something with these responses. What's your current dream job? Now, this is the interesting bit. So people aspire to be a data scientist. They want to work at CERN, LIGO. They want to be at MIT, Stanford, CMU. They want to start something up. Uh, People aspire to be a student. That's okay. Interesting. Someone wants to be a professor at Stanford. Someone wants to be a part of Google, SDE at Microsoft, and yada yada. There's like a whole slew of. Someone wants to be a mathematician. Someone wants to do MS research. Someone wants to be at ISE. Someone wants to do internal tooling at Google. Very specific, but okay, that's great. That's great. To be the CEO of my own company, Ubisoft, being a quantum scientist, MIT. I assume you want to work at MIT. Software, and yeah. So you see, it's quite a broad spectrum where I think I don't have. If I have to guess, probably 70-80% aspire to get into like a core tech kind of a role somewhere at like Apple, Google, Microsoft, Nvidia, one of these big companies. There's like a sorry, what? Yeah, Ubisoft. No idea yet, but I want to work on hard problems in physics. I really love networks and sorry, what? Cryptology, so maybe something over there. Okay, yeah, people are trying to figure out. That's a perfectly valid answer, not knowing what to do. And what you'll see is some do aspire to get into academia as well. Someone wants to say MIT, CMU, Stanford. Someone says professor at Stanford. Someone says ISC. Someone says, yeah, just be a teacher or a mathematician. So it's a mixed crowd. That's good. At least that gives me as well like a sense of where your aspirations are. This was just a like a typical sort of quiz question just to get you started. The Turing Award is generally considered to be like a big name, but there are all these multiple awards, so you don't have to really worry about them. If you were to pursue a PhD, now this is interesting. I like problem solving. That's why you would pursue a PhD. The next most frequent answer is I like the idea of being called a scientist or a doctor or a professor. Yeah, there's definitely some prestige signaling in our society where you have these advanced degrees, you're considered to be like smarter or better or whatever, and which is, but sure, I mean, there's some prestige value to it. I have enjoyed research, and that's why I want to continue research. I've never been exposed to research, and that's why I want to continue it. So yeah, it's again all over the spectrum. You see, probably it's a good way to get my parents to get off my back. Now, three of you say that. Okay, fair enough. That's also a possible reason, I suppose. But if that's the reason why you want to get into like a research full-time research program, we'll talk more about that. Yeah, if this is your motivation, then I would like hold back on it. But let's see. I like to learn new things. I wanted. I worked as a software dev throughout last year, and I got kind of bored. Okay, so someone has tried out software dev and they're bored, so they want to uh, see what research does for them. So if you were to do a PhD, how long do you think it's okay? So most people think 1 year is like the optimal waiting time. Although 10 years, I mean, 10 of you think it's fine to wait for 10 years and then consider a PhD. Very brave, Callan. I would love to hear more from you. But yeah, I think the class average is somewhere between 1 or 2 years, and then you would want to consider a PhD. Okay, that's good. And most of you estimate the research, decent research project to take somewhere around 6 months. That's a good time frame according to you. Fair enough. And I see that most of in this crowd is okay living at like, let's say 50K per month, kind of like a, let's say if I were to give you magically this amount of salary, you're okay with this salary. So that's little more than half the class. So that's also something to keep in mind. Like probably half the class is not financially well equipped where 50K is okay for them because people may have like a number of financial constraints, taking care of things at home and like whatnot. So around like, yeah, 60% of you say it's okay. That's something to keep in mind as well, which we will come back to. What do you think people do after a PhD? Become a researcher. I shouldn't have put this option. I think this is like too generic, and I wanted you folks to think more specifically of like what people become, because it could mean anything, right? Become a researcher. All of these subsumes becoming a researcher, or like at least most of them. I think 40% of you think you become a teacher. Like 50, oh wow, 56% of you think you become a postdoc, or like you try out being a postdoc right after being a PhD. That also is kind of indicative of like there being a template in our minds as to what the journey and the path really is, that you do a PhD and then you do a postdoc and then you do something and then you do something. So that's something that we'll also come to and like probably discuss in some more detail. Name two influential women scientists. I see a good spectrum of name. Grace Hopper and Ada Lovelace probably the most popular of them, but glad Joan Clark has come up. Yeah, this is fantastic. I'm glad you Babel Liskov is mentioned over there. So yeah, it's fantastic you folks are this well aware. But yeah, this is sorry, I don't know. Mira, she's inspiring to me. She ain't a computer scientist. So yeah, if you if you haven't come across influential women scientists, you should look it up. There's an entire Wikipedia page on it, so it's worth knowing what these excellent people have done for computing for us. What do you think? Did someone say Neeldhara? I'm so sad. No one did. I should have. I should have filled in this one. Yeah. Uh, what do you think it takes to do research in computer science? Okay, now this is probably the crux of this material and like this course. And I see be a very good programmer is kind of most highly represented at like 35%. Have a lot of patience, be a genius, be willing to no, which is the next best. Uh, strong grades during undergrad. Okay, fair enough. A good JE rank. Not many of you think a JE rank matters, but I think yeah, the three most representative one is have a lot of patience. Uh, be a G. No, wait, sorry, I was reading. Have an imagination and be curious. These are the three most represented ones. But close contenders are be a good programmer and probably be a genius and have good grades during undergrad. Okay, cool. For whatever the definition of genius is over here, I didn't define it. All right, this is good. So now we're knowing how the class fails and how you've all thought about it. How much do you think it would cost you to do a PhD? Most of you think it's somewhere between 0 to 5 lakh rupees, while a good chunk thinks it's somewhere between 5 to 10 lakh rupees. So we'll talk about this as well. And if you had decided to do a master's, how much do you think it would cost? It's the split is kind of roughly the same. They look the same. So you guys think a PhD or and like a master's are probably equally expensive in terms of like how much it would cost you. Can you get research by doing a master's alone? Maybe. So you're not sure. Okay, that's good. It's a concrete like way to intervene. And I won't go through this question, and because we already have an agenda, and I'll read this probably at the end of the day and see whether what we have matches what your expectation is from this course. All right, so that gives us like a decent sense for like what we think about research and how we think about the general notion of it. And let's see how much of it is true, how much of it is probably misguided or like consequence of some misinformation. But let's see. So I gave you some context as to how the origin or like the backstory behind why we floated this course, but let me kind of emphasize this further slightly more formally as to why we think this course is actually important. And it's really a tale of two stories. So I mean, it's a tale of two beasts. So like there are two sides to this. On one hand, even in my conversations and like I have like some window of to get a sense for how the faculty think about this problem of like what is going on and how students are reacting to research or the possibilities of research and so on. So that's one angle to it. And the other angle is from the student side, which I'm also technically a student right now. So I do have like a sense for what goes on over here. And if you really think about this problem or the problem from both these perspectives, you'll find like an incongruity, which I will describe in a bit. And this gross sort of incongruity between these two is really like the motivation for why we set this course up. And what I mean by that is let's try to understand this first from, let's say, the student's perspective. Now, this is again, all these things that I mentioned over here, it's like the average trajectory. It doesn't mean it's bad. These are some disclaimers that I want to put out right ahead. It's not that I'm dissing or looking down upon these trajectories. It's like a perfectly natural thing to do because either there are circumstances which would like get you to pick this trajectory up. It's the most safe, secure, whatever. There are like a million reasons why someone would go through this trajectory, but what I want to reflect on and like emphasize is the fact that this is typically what is happening if you look at the class average. So what really happens is at the end of high school, you probably all have like written some competitive exam or the other, and you've all done well there. And then you realize that yeah, you probably enjoy science. You want to do science. You get a kick out of it. Some of these subjects were like fascinating. Let's see, Verma, yay, you know, yay, and all these. Well, it's all like a nice, lovely story by the end of 12. And then you suddenly get into undergrad and things become slightly different because there's like I think an expectation mismatch of like okay for me I think doing math means I enjoyed math, I enjoyed physics, I enjoyed chemistry. As a consequence, I will probably do well in let's say whatever form of engineering that you've enrolled in. And usually people don't enjoy it. There's like a number of reasons to it. We won't get into it. But what happens is by the end of your second or third year of undergraduate studies, you kind of start losing steam. So you're like, okay, I mean, all this idealism, chalo party karte hain, and like whatever. And as a consequence, the sort of glowing idealism that you had, saying, "Oh, I'll do something in science, I'll do something in like math or physics or chemistry," and not everyone may feel this, but at least from like my experience, anecdotally, I can say at least like 10, 15, 20% actually feel very strongly about it. And this doesn't mean that everyone should feel strongly about it, not necessarily, but some people do enjoy it. And my entire sort of the context is it focuses on that small group, yeah, however small, and there's nothing against like someone who doesn't feel it. In fact, it's a good process just to realize what you're good at. And if you realize, and most people also realize that engineering probably is not something that they enjoy, and hence they look at like other venues to sort of express their interest in creativity, and that's perfectly fine. But those who do enjoy, very sharp, very smart technically, unfortunately, they lose out of steam. And by the end of the final year of undergrad, there's a general sense of apathy towards this entire process. And you get into a job, and like the trajectory, once you get into this sort of the trajectory, the path is kind of clear where you say, oh, you either switch to like you work for like a couple of years, then you find another job which is slightly more interesting or exciting, or you consider some other things like MBAIs or like a master's, or you continue in the state of apathy that you probably got sucked into. And as I mentioned, all this is fine. These other alternate routes are fine, career routes are fine. It's totally fine to be aspiring to do any of these. But if you and you have to be very honest with yourself and just ask yourself whether science and doing science in whatever shape or form you found it to be so exciting and so like pure and like beautiful in your undergrad or like right before your undergrad, where you thought you would do something like interesting and like fascinating in like science. If you were one of them and you're at the stage where you just don't feel like it, then we really should ask like what the system is doing and like what is happening and so on. It's a point for introspection. And this loss, like the group of students who miss out and like completely like just do whatever the crowd's doing and like fizzle out, whose interests fizzle out. It's actually a loss to academia. It's a loss to scholarship because probably if they had expressed their creativity in the field, maybe we would have had the next whatever, whoever, think of like the most influential computer scientist, and we would have had the next Ada Lovelace from one of your classrooms. So it is actually a loss to humanity, loss to academia scholarship if people just like drop out because of a motivation issue. And that's a problem. And even within this group, I think there are two subgroups, and the problem is slightly more nuanced. So let's say students who do have undergraduate research opportunities. So I'm specifically like zooming in on like research and how people look at research in their undergrad. So there are two groups again over here. Even this is amongst those who are still motivated and interested and want to do stuff even in their undergrad. There are two perspectives. So one perspective is, yeah, I mean, those who do have opportunities for research, the way they mostly look at these opportunities is that it's a rat race where you really need to be doing these 2, 3 projects which will look glitzy on your CV. So you do some machine learning sort of vision sort of little project, and you do some NLP and some transformer stuff and like whatever, and it looks cool. It looks sexy on your CV. Uh, and all this is being done with like this ulterior motive of saying, okay, let me get 2 or 3 good letters or recommendation, so that I can fill in an application and just go ahead and do like a master's or a PhD, or I can just go ahead and apply for like grad school. Not everybody does this, but those few who do this, a good chunk of them kind of just, this is also a template, by the way, because the institute or like your instructors in the course, there are no formal courses which kind of guide you in this direction. So as a consequence, you will ask, okay, what did your seniors do? And your seniors, so few of them went to some masters in something, and they went to the US, or they went to Europe, or they did something in India. And depending on how close you are to which group in this peer group, you will probably think that's locally the best thing for you to do. So it's just a mindless sort of thing that you want to go ahead and carry out. Some people do think it through. Some people think this is right for them, and that's great. But unfortunately, most don't. And what we really need to do is like think through where we stand in all of this at the currently. whether we are aiming for and gunning for like a master's or like a PhD, and with this as a motivator, or like with this as like the way to get there. And if it is, then we should stop and think. And that's what this course hopefully will allow you to do, where over these like hour and a half or 2 hour sessions every day, what we really want you to do is just like sit back and like accumulate this information and really think through and introspect and see where you stand in this larger scheme and larger picture and what the situation is. So this is fine for, okay, this is one side of the story where this is fine for students who have these kinds of opportunities. But unfortunately, students without these opportunities, which is probably 95% of engineering students in India, even those at, let's say, like an IIT, it's not granted that they know how to access the research opportunities that may be available to them. So it could be an information issue, or it could just be that, yeah, nobody in your engineering school it has like an active research program, and that's the reality of most colleges in India. So unfortunately for the students who have absolutely no idea about what you undergraduate research is, you just get lost out. It's whereas you could have started early. It's not that you should start early. It's not that it's the end of the world if you don't do or are not exposed to research at the undergraduate level. But I guess you miss out on quality years where you could have actually tried things, so hopped over like a few things without any consequences because you have the safety net of being in like an engineering undergrad program where you can actually try things out and like shop for like courses that you think are enjoyable. So this is 95% of the students, unfortunately, will, in my estimate, will fall into this bucket where they absolutely have no idea about research. And that's sad. That's sad because probably, and it's not that they're not smart and they're not like whatever qualities are required to do research. It's not that they don't have it. It's pretty much like a normally distributed talent curve where you go to these remote pockets of the country and you'll find people who are probably of the same caliber or better than you. It's just that they don't have those opportunities that are freely available to you. So it's a much deeper question as to one, how are we making use of these opportunities that are being given to us and which we take for granted, and two, what can be done about it, and like three, knowing this is the context, how can we improve ourselves or like make sure that our aspirations are aligned with the kinds of opportunities that we have access to. So that's the larger sort of picture, but that was from the student side. So we've understood this slightly saddish kind of a story from the student side. And now get your box of tissues. I'll make it much sadder by showing to you what like the faculty feels about uh, students who aspire to get into research. So I generally keep chatting with a lot of colleagues and friends and like professors at all these different schools to get a sense of what's going on. And it's a different story altogether that I get from them. So just a quick question. What percentage of students do you think in a batch, whatever your batch is, typically it's like what, like 60 students, 100 students, 150 students, whatever. What percentage do you think actually wish to pursue research? You could think of it locally in your current context. And just to test things out, I would encourage you to unmute and speak instead of like putting things on the chat window. Just shout out a number so that I can hear you. What percentage do you think actually end up pursuing research, or at least give it a good shot, give it a serious shot? Go for it. Who wants to be my volunteer to speak up first? I know. I'm being an instructor. Like the annoying
According
instructor
to
who gets people
me,
to speak. Yeah, good.
according to me, I think so. 2 to 5% students choose to pursue research because the
Okay.
students are
2 to
not
5.
having the knowledge about what research does it means.
Okay, sure. 2 to 5. Any other numbers? Do we want to play a game whether we want to guess whether 2 to 5 was accurate? Who comes closest to probably the right numbers?
Again,
Any other
I would
guesses?
also like to stick with the 1 to 2% mark.
1 to
Yeah.
2%. Okay. Any other numbers? Anyone who's not thinking? Anyone who's thinking above 5%?
Maybe 10%.
10%. Okay. Anyone who wants to go higher?
Am I audible?
Yeah, you are.
Okay. So I did masters in computer application from some institute, and basically everybody there was basically looking for a software engineering job. There was no interest, zero interest in research. So that was there.
Sure.
And right, so I worked in software industry for some time, and I recently took admission in a PhD program in a completely different university. And
Mhm.
there in MSc, there people are supposed to do some kind of research project. So everybody,
Sure.
like more than 50% people have some interest in research. So it's basically the environment as far as I could.
Yeah, right. So the question that I was asking, in fact, was like at the undergraduate level, rather. I should have made that slightly more contextual. So what I was asking was in an untypical undergraduate class, how many do you think end up like going for research? But what you're saying is, yeah, in an MSc program where there is a research component, sure, there is research. I mean, like let's say 50% of the students are actually inclined. But let's say in an MCA kind of a program which doesn't really have like a research component, nobody really was gunning for it, and everybody was really
Yes.
aspiring to get into a software job. Cool, cool. Thanks. Yeah. So the rough sense is, yeah, people say, yeah, between like whatever 1 to 10% to 15%, and yeah, the reality is unfortunately on the lower side of 5%. That said, unfortunately, we don't have these numbers. And in my experience and in my and what I believe is to acknowledge a problem, we need to first highlight like how severe it is and actually get the numbers out. So I'm working with a couple of institutes to actually start like documenting these numbers. I'm not sure whether Gandhinagar tracks this, and that's a separate conversation for me to have with Neil. But I think we don't know actually what the formal numbers are, and nobody really is tracking it. Nobody really is like working to make sure that this number doesn't fall below a particular threshold and so on. So there's no concerted effort as such to ensure that the research ecosystem stays alive, and that is problematic from the institute's side of things. But that's okay. I mean, that's this is not like a blame game. We're not trying to see what's going on, what's not going on, but we're just trying to assess what reality is and get a like an actual grip on like how things are as we speak in 2022. So I would say, yeah, somewhere between 1 to 2% is like a fair estimate who even aspire to get into research. Whether they actually end up getting into research is a separate question. But those aspiring to sort of consider research after undergrad, probably, yeah, I would say less than 5%. So this is from like a correspondence with like a professor at one of the institutes in India where they actually have access to like there is a good research ecosystem over there. And this is what they have to say. So let's read this out. The issue here is that undergrads aren't interested in further studies. So this is professor's view saying, yeah, we now hardly have 2 to 3 students in each batch. So that actually goes probably below 1% because these batches probably are typically more than like 200, 300 combined in terms of like BTECs, and like there are all these variants to these different courses in computing. Most students want to get done with their projects and find a good job. They're all super smart and can do great research, but it becomes hard because they tend to leave projects unfinished, not get into the finer details, move to different projects just to have a more exciting CV, etc. And these are not my words. I'm like actually without permission. I'm just like quoting directly from a correspondence I've had with like a professor. So we, as in the faculty, are really desperate to have good students. There's no dearth of research projects. So perhaps the challenge here is more about inspiring students to do good research. So this seems to be the faculty's viewpoint. And it just doesn't end here. There's more to the story than this. This was again like a recent correspondence where somebody put out like this post saying how to absolutely not write to a prospective PhD advisor. And you can see this email where they say, oh, dear whatever, I'm a friend of X and Y and I'm looking to work under you. He was telling me you're looking for a good programmer, and yes, I can do that. Please share the requirements. So from some, at least from what is written over here, this kind of looks benign. I mean, this seems like a reasonable thing to write to reach out. But there are some problems over here, which we'll discuss in some more detail in the course, and which you should also think about. If you were to reach out, and if would you have written something like this? If not, what would you have written differently? What's going on, etc. Of course, in this particular case, I think this person is like very annoyed that the student who reached out to them said they want to do a PhD in electrical engineering, whereas the professor was like a bioengineering kind of a professor or whatnot. There's some confusion, whatever. But this is not uncommon. Many professors just don't get it as to why there is this whole flood of emails that they get from students saying, let me do a research project with you. Do you have like a research opportunity? Can I do an internship with you unpaid? Can I do this? Can I do that? So this isn't uncommon. And in fact, there's like an entire question on Stack Overflow where like a professor from, I think, the US or Europe, who's just not used to this, tried to ask and understand 7 years ago why this happens. Is this like a scam? I mean, like, what is going on? Is this like another sort of, yeah, I'm desperate, sort of, give me your bank account kind of scam? Or is this genuine? What is going on in India? And unfortunately, this puts us, of course, this puts like students in bad light for sure. But I don't think we have improved very much from this template. So even today, I think if left to our devices without any more information, we would probably just go ahead and do exactly what this academic is like probably complaining about, saying, why do I just keep receiving these bloody emails? I don't understand what is going on. And there is, of course, this is a symptom. This isn't like the problem in itself. This is a symptom to a much larger issue, which we'll definitely go through in this course. So this is something to be just aware of as to what the perspective of the faculty is. And we've got, and I'm going to turn it up a notch higher and depress you all further. And worry not, I'll like pull you out of this depths of like despair soon. But just to show how severe the problem is within like the academic community within India, within the faculty sort of community, this is someone who recently posted something like this. They're 10 years in and they feel like a huge failure as a PI. PI over here means principal investigator. It means you're a faculty and you run a lab of your own. And they see themselves as a failure. It seems hard for me to keep students motivated and carry projects through to its logical conclusion. There are so many abandoned projects I'm just not able to resume, and where students are not interested any longer and they're not responsive. So this seems to be the other end of the sort of spectrum and the other end of the picture where faculty are saying there are no students, there are no students to work with. And on the other hand, there are all these students, like all of you, who have hopped onto this course to learn more about research and who are probably already doing something, who have gotten started with this process, and who really want to like get access to these opportunities so that you can actually try things out for yourself. So this divide seems very jarring for someone like me who probably has access to both these channels of information, and I just don't get it. I don't understand like how this dichotomy can exist and why this perpetuates and why this continues to exist without any systemic intervention. And that I believe is like the larger problem, and that I believe needs to be intervened. And hopefully this course, and this goes back to like the motivation behind this course, does a decent job in at least plugging this gap, or at least making the party involved, which is students, which is us, appreciate what is going on and like why do these teachers, why are they so sad and so like given up on hope when there seems to be a decent talent pool. So let's try to, of course, like peel through this in some more detail and understand what's going on over here. So yeah, it's a sad picture. I'm sorry for like dampening the mood so far. But I'm not doing. If I had lost hope, I wouldn't be doing this course. We wouldn't be doing this course. And the fact of the matter is that yeah, it's not as bad as it seems. There could be a number of things, in my personal opinion, that I could probably comment on, like the initiatives by the faculty in making sure that they're doing the right thing, etc. So it's a complex problem, and like just having like one flippant remark, writing it off, saying, "Oh, this is X's problem or Y's problem or the institutor's fault or students are at fault," does not do justice. It's not the right way to sort of treat this problem. But having understood the magnitude of the scale of this problem, yeah, I'm very hopeful and optimistic that we students, we do have like a way out. There is a way out to this, and unfortunately, it will require a decent amount of work, and it won't fit the template that you probably are already exposed to. But definitely doable. Definitely, sort of you can pull yourself out of the situation and actually have like a enjoyable journey, enjoyable process of like getting involved with research. So after like a fairly long introduction as to what the problem is and why we've put this course together, let's just make sure that now that people seem to have trickled in and like there's a stable state of like participants, let's just quickly recap logistics. So for everything, you should just go to the course webpage. Any changes that you see will be done directly over there. Any material, we'll be posting it over there. There isn't a lot of material. So out of curiosity, how many of you are just are taking this course for credit? I know there's an option for students for Gandhinagar, within Gandhinagar, to take this course for credit. So if you could like raise your hand or put a +1 in the chat, and if someone could tell me, because I don't have access to these panels of like +1 in chat, if someone could just shout out like what the number is roughly, that'll be super helpful just to get a sense. Yeah, so I think WebEx has like a raise hand or a +1 option, or you could just like type it out in the chat saying +1. So I just want to get like a rough sense of how many of you are taking it for credit. It doesn't change anything. I just want to know, just for our information. Do we have like a number sense? Neil or anyone who has access to the, let me look at Discord probably. Something going on over there.
So, Shashank, are you able to see the chat or just?
No, I'm not.
Oh,
Unfortunately, I'm not. Yeah,
oh,
there's something weird with this interface, which just hides that chat toolbar away.
right.
Oh,
So,
I think I figured it out. Wow, 2022, and I'm still stuck in trying to figure out where the chat window is. But yeah, no, unfortunately, no. Sorry, no. The
yeah.
answer still remains no.
Yeah, sure. So I guess, there are 15 enrolled students from
Okay,
IITGM.
that's great.
There's a few of them who wanted to but couldn't join because the
Sure,
first
absolutely.
orientation program going on, then they have
I
activities
see.
24/7.
I see.
So
Sure.
they're catching up with the recording. And Satyam
Got
says
it.
hi in the chat from IDGN, and a few people have confirmed that they're not doing this for credit, but they're probably here through NPTEL or other references. Yeah.
Fair. Fantastic. So yeah, I mean, it doesn't make a difference, much of a difference. I think if you're taking this for credit, you'll have to probably actually turn in like a small exercise that we hand out to all of you, which will just again get you to practice these skills and actually concretize and instantiate these skills, rather than it being just this big jam session where one of us is talking and all of you are just listening and there's no action at the end of the day. And of course, it's not restricted to anyone. If you can make it through these live interactions, great. Otherwise, we're going to put everything. We're going to record these discussions. The sole the best bet for your time in sitting through these classes is actually these discussions and facilitations and so on, because the content is all there. We're not going to deviate much from the content. And you've got the Discord server, so you can always ping stuff offline, and one of us will man the chat and we'll respond to you. But for you to actually derive some utility of like being in this particular interactive session is to actually interact and like make sure you're asking questions, interrupting me, stopping me, getting things clarified, and having a conversation. That's what I'll probably enjoy the most, rather than just like going through these slides and like conveying information in a dry fashion. So that's the logistics. If there are any questions, feel free to bring it up now, or I hope all of you have access to the Discord server. Feel free to hammer away over there, and we'll discuss it over there. And this introspectively should also ask me, because we're in this process of introspection, the question is like, why am I here? Why is it like I am talking to you about all these things, and why is it that me and Neil are doing? Why just us, and why not someone else? And that's an important question to ask. And any guesses as to who this person is, whose photograph has been put up on the slide? Feel free to shout out the name if you know it. No one. Some of you could probably do a reverse Google search, but yeah, I mean, don't worry about it. So this is
The chat, I'm
yeah.
not sure if you are.
No, I'm sorry, I have no access to chat. I'm sorry.
That's fine. So I think Yashaswini is suggesting Feynman, and Sunny is saying the transistor person, Bardeen. I don't know if I'm
Yeah,
pronouncing
sure,
that.
shortly. Okay, yeah, but yeah. So it's interesting. He worked very closely with the transistor person, Shockley, William Shockley, I think, Bardeen and Shockley, so Warner Shockley. He worked at AT&T Bell Labs. He's not Feynman. This person is Richard Hamming, who's quite a
So,
popular name in like.
yeah, Varuna, I would say having so, yes.
All right. Okay. We've got one good answer. All right. Yeah. So, yeah, this is Hamming. And if you've taken like an course in information theory or like communication systems or even probably basic electronics, like the first digital electronics, intro to electronics kind of stuff, you'll see Hamming distance, Hamming matrix, Hamming whatever, and so on. And he was the third recipient of the Turing Award, which is like this big award given out to people who do like foundational stuff in computer science. And Richard Hamming has a talk on like how to do research and like how do you think about research and like what's the right sort of ideals to aim for and so on. And it makes sense for Richard Hamming to be talking about these things given the credibility that he has in like coming up with like interesting research. And unfortunately, I definitely don't see myself. I'm not sure about Neil. I'll have to ask her. But we are not Turing awardees standing in front of you and trying to tell you how to do research. And that's not the intention. But rather, the intention is all these great people who have done foundational stuff have actually put out what they think are the ingredients to do good research. And our job is really to take that information and like just present it to you in a slightly more structured fashion. And the reason why we think we can do that is because we've been through this grind ourselves for like whatever 10 15 years, for the last 10 15 years, and that gives us at least some vantage sort of advantage or like a of like looking at this from like a big picture perspective and just try to assemble and piece together all those pieces of information. So nothing that I will say or Neil will say or what we're going to say in this course is something truly our own, like truly something that we've some insights that we have come up with after having like chatted with each other over the last 1 year. These are all insights which have been like laid out by all these folks who have like quote unquote best practices on like how to be successful at research. But the unfortunate thing is there are just so many resources. There are like everybody puts out, every professor out there puts out like a page on saying, if you want to work with me, do X, Y, Z, or like do 10 things, and this is the best way to have like the best research experience and whatnot. And someone who's reading through like hundreds of these documents will say, "Arey bhai, chal kya raha hai?" I mean, like, give me some like something consumable where I can actually start off with. Otherwise, it's so overwhelming just to begin this entire like space of understanding what's going on or like how to think about this. So that's the aim of this course, and that's what courses do best. Instead of asking you to read 20 research papers and try to understand, let's say, what databases are, there's a course which actually teaches you what databases are, having distilled all those concepts in a nice, sort of consumable, palatable fashion. Uh, and it's also important to understand what this course is not. So this is like a very popular trick which Eastern philosophy uses to answer anything. They answer in negation, saying this is not it, this is not that, this is not this. So in the same style, let us also try to understand what this course is not first, and that will help clarify what this course really is about. So this course is definitely not this one big Gyan session where I'm talking to you from this pulpit saying, oh, this is the way to do research. And if you do what I've done in my life, or if you do what Neil has done in her life, you're definitely going to be like whatever, like the best researcher on this planet. That's not the intention. Again, just to like emphasize this again, we're just presenting information in a more structured fashion. And really the hard task of this entire course is you actually doing work. This information can be consumed, this entire course that we're doing over like 6 days, just so that it doesn't become too overwhelming. We're spreading it across 6 days or 5 days, whatever. But the gist of it can be understood in like 2 hours flat. So then the real question is, okay, this is like a 2 hour thing. I mean, like why all the hoopla around it? And the only thing there is the catch and the caveat over there is most of us tend to are like tempted to just consume knowledge. So we listen to all these podcasts and we do all these readings and we read all these pages on Reddit and read all these blogs and whatnot. And we are consuming and we're consuming and we are trained to be consumers. Our high schools teaches us to be great consumers, undergrads to some extent, and so on. And the general default setting in our brain is to just consume knowledge. And what do you do with all that knowledge? You need to act on it. You need to produce knowledge for it to actually translate into something which people can actually see. And what we'll see through this course is what matters more is what is the portfolio that you can present, saying these are the 10 things that I've actually worked on, rather than saying these are the 10 things I love or I'm passionate about, I have like great interests in. All those words just become fluffy words if you can't back that up with like hard, like actual skills or like hard work, right? So that's a key message that we want to drive across as to what this course is not. This course is also not like a counseling session where we tell you how to write your recipe and how to apply to grad school. I couldn't care less for it. If you do it, great. If you end up like writing a good uh, SOP or whatever statement and like you get through that game, fantastic. That's not really my intention. That's not is our intention. Our intention rather is to make sure is to get you to stop, think before you actually apply, and be sure that you actually know what you're doing. And that's really the aim. So in the crudest analogy that I can think of, let's say you've decided to marry a person, we'll come in and say, okay, that's great. This is great that you want to marry this person. But like these are the 5 things you should really think about. I mean, like it's all beautiful. It all seems lovely from like the outside that our life would be beautiful with this person. But these are realities, and there are these 10 things that you should probably have to answer for yourself. And just do that reality check now so that you have fewer miseries going down the line. And as surprising as it may seem, I study at like MIT, and even at a place like MIT, students come in with like wildly off the mark. I mean, their aspirations are somewhere and the realities are somewhere else, and it's completely off the mark, and they end up having like a miserable time. And so this immediately sort of should tell you this has got nothing to do with your technical know-how, how smart you are, how sharp you are, etc. All those aside, do consider a research sort of field in research because you think you'll do well or you have some initial sense or exposure for doing well in it, and then you'll actually enjoy that process. So right after 12th, probably 12th grade, we didn't really have that much information and we blindly picked CS or chemical engineering or one of these engineering fields. Don't make that, don't let that happen to you again. Now you actually have enough time, access to freedom for you to actually sit through and actually deliberate over it and make an informed decision. So that's the logic. Yeah. So to conclude, I mean, this is this is an introspective course. It is completely for you to actually see how all of this fits into where you are currently or what you have done, what you need to do, etc. And I would say this is probably the let me get the mouse pointer. This is like the biggest thing that I would want to convey, saying separate this romantic notion of doing research versus the realities of doing research and get a good sense for it. That should be your aim if you want to try out like undergrad at the to try out research at the undergrad level. And a weakness of this course is it's very easy for anyone to say this. I mean, to tell you what this larger mental model is to think about and so on. Anyone could say it. Anyone who may be good or bad at research. I don't consider myself like great at research or anything. And I'm like, I would say, okay. And even I'm like doling out this advice means that, yeah, probably anyone can. But that's not really well, that's not the hardest part. That's the easiest part. The hardest part is you contextualizing it to your constraints and actually getting work done. And we'll come to it. We'll try to tease this apart and try to put some more details into it. There's also this disclaimer that I want to add over here, saying don't, which I'll probably come to later as well. So enough disclaimers. Yeah, I mean, let's skip past. We're already at like past 1 hour. However, we organize this course. There are 3 sections. You'll find this again on the webpage. So yeah, we can go through this as we cover each module. So the first 2 modules are just big picture, like what research is and how to think about this problem, and just giving you more information on what these programs entail. And the next 2 modules, the third and the fourth module, is where we'll actually get into the implementation aspects of like how do you actually get started, who do you talk to, how do you talk to them, etc., etc. So that's what's in store. So I think we've any questions. So let me just pause over here and take questions if anyone has any lingering questions so far. If not, we can probably go ahead and I can cover like one or two into like topics that we have in mind. So any questions so far? If there are, I mean, I can't again look at the chat. I'll work on it later this evening. But if someone could tell me if there are any questions, that would be really helpful. Or you could just speak it up. I mean, you don't have to type it out.
Yeah, I suggest that folks who have questions at this point feel free to just unmute yourself. I think it'd be quick.
Yeah. Yeah.
But yeah, so I guess I mean I think there were like a couple of logistical questions that came up in the chat, and I
Sure.
think I addressed them in the chat, so that
cool.
should be okay.
Cool.
So yeah, let's just give it like 30 seconds. Please feel
Sure.
free to mute yourselves if you have questions. Nice.
Also, a sign of no questions is, oh, I'm sorry. Damn it. I couldn't like drop my punchline, but go ahead. Good. Someone said or started saying something.
Sir, I'm not sure if my question is valid currently.
Go for it.
Like maybe you'll cover it in a future module / section.
Go for
But yes, my question is basically, I have interest in computer science, but I'm currently not pursuing it. I'm currently pursuing chemical engineering, and
Sure.
not exactly like I did not think much at the
Yeah.
point of counseling and everything, and I realized it later. So
Sure.
can I still do it? But I think you might cover this later in.
I will. I definitely will. So yeah, we'll talk about things like not being from like a CS background but wanting to do research in CS and so on. Yeah, sure. So we'll definitely come to this. Any other questions? All right. So we can move ahead. Let's play this game for the sake of formality. I mean, I say game, but it's going to be a little slightly boring game given the games that we play.
Shashank,
Yeah. Mhm.
yeah, sorry to interrupt you, but I think Rahul
Yeah.
has a question in the chat asking if
Sure.
you could address demotivation working through hard research problems.
Sure. I mean, we'll get to it. So that's something that these are the more concrete sort of instantiations of the reality, sort of like starting research and like working with research. And the sort of 3-second, 5-second answer is I probably don't have like a great answer for that, but let's actually try to understand that in some more detail. All right. So the importance of research.
Right. So
Yeah, go ahead.
yeah. So Ravinad asks about your opinion about doing a PhD right after BTech.
Yeah, I'll get to that as well. So in fact, this entire course, hopefully, after like module, let's say 4 or 5, I will. Who asked that again? I'm sorry, I didn't get the name.
I think Arun Ravinad.
Arun
Yeah.
Ravinad. Okay, so I hopefully Arun sticks on till like whatever, like module 4 or module 5, and then we'll open the floor up and we'll probably get Arun to reflect on like an answer to that question. So I'll pause on that question and I won't like I'll park it. I won't answer it right away.
Okay.
But that's
then,
that's the aim of the research.
Right. And there's, I think, a couple of more questions that have trickled in. So Utkarsh is asking if there is a difference in research done by university professors and research done in industry labs like Amazon, Meta, etc. And
Sure.
I believe that's also something that you plan to address explicitly. But I'll just quickly cue in the other question as well, which is from Sunny. Sunny is asking if researchers are underpaid and undervalued. So I guess, yeah, there's a couple more. I will address one of them at least in the chat. And then I think if you want to address this bit about either the difference between university and industry research and or researchers being underpaid and undervalued, you could do that.
Yeah. So Utkarsh says research industry versus academic. We'll get to it. There's in fact like a little blurb on the course webpage in module 2 as well, which we may cover end of today, tomorrow, one of these days. So I'll definitely talk about that. Sunny's question on whether researchers are underpaid. That's also like an important question, which is why there was this question in your initial survey as to whether you're okay living on, let's say, 50K a month for the next 8 or 10 years. The short answer is, I would say researchers are not underpaid. I think you're paid, the parity is all right. But there are lots of like nuances and caveats to this generic statement. But let us these are all great questions, and hopefully as we go through these modules, you will build along with me this larger framework to think about these kinds of questions and answer these for yourself, given that you've understood like some facts about how this game is played. And then, sorry, what was Arun's question again?
No, no,
Uh,
I think you addressed both. Arun was earlier asking about PhD after BTech, and he had a follow-up.
oh, sorry. Yeah. Okay.
Yeah.
Yeah.
Yeah, I think you had a follow-up question on getting a PMRF while doing a PhD. So Arun, I'll try to take that in the chat. Although the short answer is that that's a fairly specific question pertinent to, I guess, PhD programs in India, and they sort of
Yeah.
have their own process. And I don't know if you plan to delve into specific fellowships, but I think we will have like general pointers about things to, parameters to watch out for. And Yashaswini asks, or I think this is also more of a comment, I guess. So, when I was a kid, I was drawn to research, the idea of being a scientist. It's like a childhood dream that I'm not able to shake off. I don't know why it's stuck in my brain. I'm a mom to an 8-year-old, but I feel the urge to chase my dreams. So first off, I think kudos to you for sort of keeping at it. I think Shashank will, I'll let him react to it. But very quickly, I think Nishant is also asking if you will be talking about managing finances during a PhD, as it's a long duration commitment. And if you don't plan to get to it, then maybe you can share some quick pointers. And Yeah, I think there's a bit of a discussion going on in the chat about researchers being undervalued. And yeah, so I think Arun continues to have a couple of, I think, questions about fellowship. So I will try to take that a little bit in the chat. But if you want to address Yashaswini's comment, maybe, and Nishant's comment about or question about managing finances during a PhD.
Sure. Yeah. No, this is great. These are all like such good questions. I'm like so glad this interaction is ending up. This course is ending up being this interactive. So I'll get to Utkarsh and Sunny's questions, whether researchers are underpaid and like industry versus academic. Yashaswini's childhood dream. So this is like this beautiful story of idealism, which many actually exhibit. So it's yeah, it's something irrational where you probably would have been exposed to. Even me personally, like I can share like something that I happened with me personally. So I think it was I grew up in Bangalore, very close to the Indian Institute of Science, and nobody in my family is an academic. But then the school was conveniently very close to the campus there. And for those of you who haven't had the pleasure of visiting this campus, it's a beautiful campus, one with like a pristine block of nature in the middle of the city. And weirdly, I was just drawn, like completely fascinated by the campus, and all by myself, I would just walk around the campus and so on. So it's there is a there's something drawing me to it. That doesn't mean anything. It could mean something. It couldn't mean anything. Interpretations are like you could interpret it the way you want to. But there was always a pull, and I can relate to this kind of childhood dream that Yashaswini also talks about. Uh, Unfortunately, where we, I think, all uh, get shortchanged just going through life and this entire process is the fact that we never get to translate those idealistic sort of fascinations that we have into actual concrete research. So we don't get those streamlined opportunities where you can actually sit down and really apply your skills and get started with it and get a good concrete feel for it. I remember asking my father, in fact, when I was 12 years old, saying, "Is it true that if I like something, I'm actually going to be good at it?" And that's a very existential sort of thing that I think we all face at all stages of our lives, saying, "Oh, I find this so fascinating. I find this so beautiful. I still find math beautiful, for its beauty and whatnot." And I pretty much, I would say, not suck, but I'm not great, so I'm not good. So it takes me a lot of effort to do decent math. And like, when I say effort, it means like conscious effort where I'm like giving it almost like my 90% or 100%. That's the effort it takes to go through like the mechanics of doing math. And it doesn't come naturally, or there's no flair, or like where I can just see something and it just like pops into my head. That doesn't happen, unfortunately, or like fortunately. But that's the reality of doing research in math. So if I were to do research in math, irrespective of what my fascination, affinity, or degree is, I really need to be able to spend that effort, and I need to be able to enjoy spending that effort. If I find myself applying 90%, 100% of my energy into, like, let's say, solving a problem in math, and that process itself is so annoying, it's so tedious that it puts me to sleep, it's just like, oh, man, I'd rather go watch something on Netflix kind of a situation, then it's a unfortunate like reality check where we need to constantly say, okay, is there like enough of a draw? Is there enough of a draw? And you keep going back to it and keep trying this out. So full props to you for like still having this drive and this fire in you. And these kinds of idealistic fires, or like these spirits, usually is what like pushes people through the kind of drudgery that you actually end up doing when you do research. So unless there's some sort of like ulterior motivation that you have, saying, I want to see this beautiful result, the journey will be through like layers and layers of like crap, but that result, the aesthetic of that result, or the beauty of that result, is something which will hopefully drive you. And I can only convey my best wishes to make sure that you actually discover this path, or like this concrete setting where you can actually apply yourself and like realize this ambition or like aspiration. So those are my slightly long response to that kind of a thing, but it's good. It's great. I would love for everyone to be that idealistic. I mean, that's what makes this planet like tick, I suppose.
Fair enough.
Oh, sorry, Neil, I think you may be on mute. Yeah. Okay. Okay.
Yeah, I think.
So no, that's perfect. Nishant, with respect to PhD and managing finances, I'll talk very briefly about it, nothing in detail, so I could probably also look for some resources and send it your way. All right, so we're 20 minutes past the hour, so let's chug along. So importance of research, I don't really want to dwell too much on it, but because I think it's very self-explanatory in some sense. But if someone wants to give me like one innovation that they think is cool and they know came as a product of research, or like consequence was a consequence of research, feel free to shout it out. I just want to make sure this is more of like a way to get you to interact and like just have like a little conversation about this, and for me to learn if there's any interesting innovations that you know about that I may not know about. So feel free to just shout out any innovation that you think was a direct consequence of research, or like some sustained effort by an individual or a group of individuals, which led to that innovation, and then we just reap the benefits of it as of today. There should not be this much of a zinger, but
Yeah,
anyway.
so relativity and GPS have come up in the chat. This is from Satyam.
Oh, relativity and GPS. Okay, all right, yeah, fair enough. Yeah, fair enough. Yep,
And
that's
you
a
got
direct
proof
consequence.
of Fermat's last theorem.
Proof of Fermat's theorem. Okay, yeah, fair enough. I mean, that's a nice mathematical result, but I'm not sure what innovation you see in front of you, which is a direct consequence of it. I hope there is something to it. Is it used in cryptography, Fermat's last theorem? Probably. I don't know. It could be like a primitive in some. Yeah.
Yep, no, I don't have any specific intel on that. Rahul has a pointer to Attention is All You Need by Vaswani et al.
Oh, come on. All right. Well, okay. All right. We're playing the new game now. Okay, sure. Fair enough. Was money at all in Transformers is like a thing, sure. But more classic stuff. I mean, COVID, we've been through like 3 years of like absolute drudgery, and like we got out of it because of these vaccines, and vaccines is like, again, like a direct consequence. So biomedical, all innovations in medicine is essentially just like a consequence of research, where for like 5 years, 10 years, people just quietly just keep chipping away at like one small idea, and that ends up being something of like great consequence. So, in fact, a book that I would recommend is probably The Emperor of All Maladies by Siddharth Mukherjee, which talks about like cancer and how we know what we know about cancer today. And you'll find the process, the research process of like discovering radiotherapy, chemotherapy, etc. is like a wild process. So it's a good read just to get a sense for like how things have evolved. More concretely, closer to home. Oh,
Sorry,
sorry.
I was just interrupting you to say that Nishant is talking about quantum mechanics and semiconductors leading to transistors, and God of Shah
Yeah,
says capacitive batteries in EV cars. So
yeah.
yeah.
No, all those are like legit innovations. I mean, without battery technology, without like understanding the chemistry of like these substances, we just wouldn't have any of these technologies. Yep, fair, fair. So closer to home, this is something probably most of us don't know. For like, thankfully, it's called Kala Azar. It's a sibling of malaria, so to speak. It's again like a vector-borne, like a thing where a mosquito carries this parasite, and it like really takes out like 30,000 deaths even today, unfortunately. So your skin tends to become like dark, and like sort of there's like a blackening of your skin, and your liver is bloated up, and like it's just like a very painful way to suffer through this consequences of this parasite being in your body. And what not many people know about this, but there was like a, again, I would call like a maverick scientist slash researcher slash doctor clinician who was at the center of this investigation, and actually in the 20s came up with like a solution for it. And we must really be thankful to him for his like continued effort without like any resources. I mean, we at least have like resources at our disposal. This man went through like a fair bit, and but just kept at it, and we have a cure for this horrible condition because of the efforts of this one person. So I've put up like a little PDF in, I think, module one or module two. It's like a nice little article which gives like a biographical sketch of about Upendranath Brahmachari. So more closer to more recently, you should definitely look up Gagandeep Khan. She's won many popular recent awards for her work on the retrovirus, and like just informing us more about how viruses operate in the human body. So this is something much more recent. And she, of course, she talks a lot about like creating a culture for science and whatnot. So if you want to re-spark or rekindle like your enthusiasm and idealism for science, do listen to her speak. Again, the trap is, with each such pointer or resource that I'll send you away, I'll of course put a disclaimer on it saying it's very easy to get lost in the sea of like watching videos and feeling good about yourself after watching all these TED talks and like people talking about like how to do science and do research. All that is meaningless if you don't end up doing it yourself. So keep that harsh disclaimer always at the back of your mind, saying, sure, I'm watching this. I'm probably watching this because I'm like brain dead from doing hard work through the day, but focus your energies and effort on actually getting stuff done. So this is what I'd like to spend at least the next 15 minutes talking about is research for me. And if it's not for me, what do I do? And so on. And like we saw in our initial survey, this was the question that was asked to you for you to assess whether research is for you. And this probably tries to probably some questions, probably not, but let's see. And what do we think are the qualities? And most of you in your survey said you need to be curious, I think, have a lot of patience, have an imagination. These were the three biggest, most of you voted for this. And then came be a genius. Uh, Nobody thankfully said this, saying let's discard good hygiene. Strong grades during undergrad was one of the options that most of you picked. And be a good programmer is something that you all picked. So the reality is, yeah, I've personally met, at least this is anecdotal, but I think most of them will tell you the same story, that intelligence is kind of, however you measure it, is kind of underrated or like overrated in this research game. And what really matters are things like how doggedly you want to go after like a problem. So again, think of the very common process which almost every PhD student also faces, or anyone who's doing professional research also faces, that you can dish out ideas uh, like a dime a dozen. I mean, like you can like just keep coming up with ideas saying, "Oh, if this, what? If that, what would have happened? If that, what would have happened?" And usually, all those ideas are useless, most of them, unless you actually work on it and take it to its logical conclusion. As like one of the people who had posted about their sad state of affairs with respect to their research program. So seeing things through is usually the secret sauce in any research project, where you have like a rough idea of like how to solve it, but you keep trying, and then you learn things on the way, and then you realize, okay, probably how you were thinking it was not the right way, and then you think about it in some other way, and then you get an insight, and one day you have this aha moment, and then you make some more progress. And what this tells you is you really need to be willing to spend that kind of time and mental energy on a problem where you think about it on and off for like a long period of time, because there aren't like established solutions to any of these problems that you're likely picking up. And yeah, it's just hard. It's by the design of it, it's supposed to be hard. So it's like, let's say, I getting you to learn chess or swimming or any of these things. So if you've never done it in your life, try swimming, and you'll really find it to be one of the worst things ever you could do. You'll like flap your arms, you'll probably sink, you'll ingest like a ton of water, your lungs will fill up, and it's just a miserable feeling the first few days. But there has to be something that draws you to that process. There has to be something saying, "Oh, you know what? I really want to be able to swim this lake. This lake is just too beautiful for me not to swim in." Or like whatever. I mean, I love water. Whatever. There is something innate in me which keeps drawing me to this swimming pool. And then you really need to be able to tell yourself that I need to put in this work. And the only way you'll improve at swimming is by actually swimming. And of course, an instruction here, a nudge there will, of course, make that process much more manageable. But you, at the end of the day, you really need to enjoy it. And if you don't enjoy it, there's nothing anyone can do about it. You may be working with like a Turing Award winner as your like advisor or mentor. They really can't help you if you don't really enjoy it. And unfortunately, this part is underemphasized in this race to accumulating CVs and like this glitzy CVs and like having all these letters of recommendation and whatnot. It's like, okay, you have the CV. That is the game you need to play to get into like a decent grad school and get like a good grad experience. Sure, fair enough. Play that game, but you play that game wisely in the sense that before you play that game, also know that there is something that you truly enjoy, and this process, this grind. Because let me break this myth, and this I will authoritatively break and like claim to break, is that yeah, it's very unlikely that you'll just scribble something on your paper and it'll be this equation which everybody will like take notice of and will be the next big thing. It's a lot of hard grind work. I mean, like ask any chess, if you play chess, ask any player who professionally plays chess. It's the most, I mean, like I can't emphasize the word most enough, most mind-numbing thing ever that you could do. It's doing the same thing, looking at those 64 squares, going through the same positions over and again, doing the same puzzles, same kinds of puzzles over and again. You're not learning anything new, but you're like fine-tuning it ever so slightly to get better and better. And that is kind of like a loose analogy. I'm not like a big fan of providing these kinds of analogies, but that's the kind of loose analogy that I can probably relate to when doing this kind of like a course or picking up a skill. It's the end of the day. At the end of the day, you're picking up a skill. It's like jump rope, skipping, anything which doesn't come naturally to you. You just have to spend so much time in improving that it just takes a lot of time. But what is killer, or what needs to be killer, is your instinct for it, your aesthetic sense of appreciation for it, your aesthetic, and those will what will fuel you through that grind. And if you don't enjoy the grind, you're likely not going to enjoy research as a whole, because in my worldview or in our worldview, research really is that process. It's not some end paper that you publish or like whatever. It's that entire process of doing that, going through that drudgery. But that drudgery is very enjoyable. I love it. So there are people who love it. It's perfectly fine. And some people get a kick out of it. And this is like an important disclaimer for people to actually internalize. And I'll keep making this over and again through the course of this course, that it shouldn't be a reflection on something that you lack. This is not like a zero-sum game where you gain something, you lose something. It's it's a reality that you need to probably reckon with, and you probably have to do a good job at first establishing as to whether you enjoy research. And if you don't, you don't. Big deal. I mean, I don't enjoy doing so many things. I mean, which people like really love, and like I'm like, I sit at the sidelines and say, oh, what a bunch of weirdos. Why would they spend their time like doing this stuff? I don't. But the unfortunate thing with research is there's a social status associated with it, which which makes it hard for people to let go. So again, this is not like a pep talk for you all to just let go of research and like say that this is not for you. On the contrary, it's the other way around. But I also know people who don't want to let go simply because it's like, what will society say, or what will like people think about me, saying, oh, I'm dumb and I couldn't do research, and as a consequence I have to quit and like whatnot. No, it's just that you didn't enjoy it. Big deal. I mean, like there are so many things. Life is like varied enough where you can enjoy like a bunch of things. And if research is not one of them, it's not one of them. Big deal. So that's I hope that by the end of this entire course, this is like the larger sort of Zenish kind of attitude that you all imbibe into like considering whether like research is a good fit and like actually going through that process and enjoying it. Because if it were like a 1 year course where the structure is fixed and like you're being told to do, you're being given exactly like a fixed chore or a task, and you're being told exactly what to do, then this degree of introspection is not needed, because what will possibly go wrong? I mean, it's like a 1 year thing, right? So even if you don't enjoy like an MBA, going through like a 1 year or a 2 year MBA is not that hurtful in terms of like how much it'll demand of your like mental and physical sort of space. But going through research is slightly more elaborate. You need to first learn a subject, you need to then gain some mastery over it, then you need to be able to apply it somewhere. And that can become super painful if you don't really enjoy it. So that's something to keep in mind. And that's why it's worth spending this time and deliberating over it and introspecting over it before you actually jump into it. So how do I start off? Now, this is the first sort of question which kind of pushes us towards being more concrete. And I want to probably stop in like 5 minutes or so, so that we leave room for some discussion, and it's yeah, if people have more to say, they could probably say. So yeah, so how do you start off? And this is again like a thing that people sort of find is not cool. So unfortunately, there is a culture usually when you get into undergrad saying if you focus too much on your courses, oh, you're a nerd, you're a gisu, you're a this, you're a that, and you're not like part of the cool hip gang who probably wants to do crazier things because itna sab kuch, I'm sorry, I'm switching to Hindi. Probably I shouldn't. We've slogged our butts off into getting into whatever college that we did. Now it's time to party. That's a fair way of outlook for looking at life. That's all that is great. But if you really want to consider research, and if you want to like go ahead and like reconnect yourself with that past idealism that you had, then probably the most concrete way is for you to actually be serious about your coursework. And the reason why I say this is because it is like this stepping stone or like the window to the kinds of problems that you may be excited about. You need to get this information from somewhere. And what better place than like an actual coursework where someone has like curated something for you and like put things out so that you ingest it in like a nice structured format. And there too, there's a lot of hard work then as to push the boundaries a little and say, oh, if not this, then what? So not reading a course sort of material as like a novel, but instead like actually deliberating over it and saying, oh, they say you can do like whatever deadlock detection like this. But I mean, like, what if you could do it like this? So this what if question is central. You need to be curious. One of the qualities that we established previously as being probably important. And this curiosity mixed with this constant drive with like hammering away at like, you give me a concept and I'll ask you to defend it, I'll ask you to justify it, I'll make sure that I've understood it like thoroughly well enough. This kind of grind not everybody enjoys, but if you do enjoy, coursework probably is the first best place to start things off, and people don't appreciate it. Now, you may have related questions saying, oh, does this mean I need to get an A in the course? Again, those are very wrong, incorrect, so not incorrect, but like a very naive way at looking at all these things. Nobody cares what your grade is. I mean, the people do care. Let me hold back on those kinds of like generic statements. Grades are sure they have their place, but what is infinitely more important than grades is like how much you really get out of like a course, how much your understanding is. I see there's a question. Someone's raised their hand. Go for it. Yeah.
So, I mean, you mentioned that grades are not that important, but like
No, no,
people
no.
do
I'm
care
sorry. I'm
about
sorry.
grades.
No. I would like to scratch that off the record. So there's a nuance to it. That's not like a blanket statement that I want to put out.
Okay.
But yeah, sorry. Yeah, go ahead.
Okay. So, I mean, from what I understand, like if your GPA is too low, that's considered negative. If it's too high, then that's an added advantage. But if it's somewhere in the middle, it's like, yeah, okay, you're passing a checklist and we'll look at your application from a broader perspective. Let's say if a student has like kind of measly B's and maybe even a D minus in their first 2 years, but then in the third year, and if they do a fourth year, they really improve their work ethic and like get into it and manage to get like good A's, A pluses, and even some research experience. Um, does that upward trajectory count? And like, if there is an explanation behind like scoring really shitty in the first 2 years, and then like there's a definite upstreak to in the latter half of their
Sure.
undergrad journey.
Okay, all right. So there are a couple of comments that I like to make over here. First is like the way it is framed currently is that grades are good. I mean, like having high grades are good, having low grades probably not good, having somewhere in the middle is all right. And the question is to whom? I mean, like, of course, I think the implicit, like, sort of what was tacit in your question was you wish to apply to like a graduate program, and someone who is like reviewing your application will probably be going through these metrics to evaluate like whether to get you into their program or not. But even we still haven't gotten there yet. So this is the thing that we really need to crucially sort of dissect and sort of separate. There is this process of applying to grad school and sort of seeing whether grad school is going to be like the destination where I want to spend like a couple of years learning to do research and doing research. But the core content of this course also is like a step before it, where saying, sure, there is a point where you'll have to actually start thinking about grad school and thinking about applying. But there's a ton of work that needs to be done even before it. Even for you to get to that question saying, should I now look at grad school as like a possible sort of option? But that doesn't answer your question. And what you asked is like a valid question, and I will get to it. But at this stage, all I'm asking, or like what I'm trying to emphasize is this is far removed from the process of actually what is like the consequence of you going through like a research experience in your undergrad, whether that leads you to actually do research in a grad school setting, whether you say, okay, I did it, I enjoyed it, but yeah, I mean, that's not something that I want to do. Let me go ahead and like get into like a software engineering role or like some other role. That's also like a perfect exit, which people underappreciate. So what I'm trying to disentangle through this entire discourse is there are two components to it. One is, of course, this application business, which is a game. You need to play that game well. There are these little metrics because it's a supply demand problem, right? There are so many people applying. There are so few spots. And then how do you like, how does the institute like filter? That's a valid question. But that's really not the crux of any of this material currently. The real take home for at least from this slide and the few slides before is like, let's try to focus on discovering what we are really interested in. And that really should be the goal, because interestingly, you can play this game two ways of like applying to grad schools. You can play this either exactly in the template form, which we are all used to saying, get good grades, get do this, do this, do this, and then go ahead and apply. Or which people don't really talk about much, which in fact I think personally has a higher success rate of actually getting accepted in like a grad school setting, if that is the end goal that someone has, is to actually discover something, is to find a niche that you have sort of stumbled upon, this problem space that you actually are bothered by. It actually irritates you. It like for some people, like walking on like a footpath where the footpath is broken, it irritates them to the extent saying ki, how is it that as a society, as a civic society, we have broken footpaths in 2022? Why can't we get our act together and have just recent footpaths and roads? Of course, many are irritated. Everybody rants. So Twitter is full of ranters. The social media is full of ranters. After ranting, some people actually go ahead and start working, saying, "Let me go to my local corporate, my ward office, ask them what is going on, see what is going." So people who are bothered by a problem enough that they actually try to invest their time and effort into solving something or like seeing it to its logical conclusion, that's a whole different game. And unfortunately, 1% or even probably 1% is too much, too big a number. Unfortunately, it's just not in our ethos to like go through this experience and go through this route of like figuring out what we are good at and like actually getting something done because we are like bothered by it. And it takes time, unfortunately, for you to find that voice, for you to find that sensibility saying, oh, this is something that I don't enjoy. Because opinion without knowledge is just like hot air, right? I mean, you without learning anything, without knowing anything concrete, if you have an opinion saying, oh, transformers are good and CNNs are bad, it's like a stupid like machine learning analogy for those of you who follow it. It makes no sense unless you have the technical toolkits to actually reason about it critically and are bothered by something specific. So it's not enough saying, oh, India's economy is bad. It's sure, whatever. I mean, maybe good, maybe bad, nobody cares. But if have you found something very specific that you think you can intervene in? Have you found something which is close to your college or your like hostel or office? Even your hostel, saying one specific problem is probably something is unclean constantly or something of that sort. So the specific problem is there is let me start a liaison with like whoever the ward official is and like the hostel official is and have a dialogue and make sure this system comes in place. And doing that has given you street cred, has given you that experience of learning about that one bit in some more detail. So now you understand the process of how does the warden delegate like a team to come and clean this place up. Then you go speak to the people who probably are involved in the actual cleaning. Then you learn from them. So now you become like a domain expert in like just understanding how this funnel of the system works. And that's similar with research. So it's so broad, it's so wide. When someone says, oh, I'm interested in computer science, I'm interested in machine learning, I'm interested in AI, it means really almost nothing. It's like almost vacuous information. Theoretically, it almost conveys no information. What does convey information is saying, I found this one interesting project which seemed to be doing, let's say, gesture recognition. I played around with it, but what seems to be an unsolved problem is like, how do you map gestures to like words or something of that sort? I'm just making all these examples up, by the way. And that's a very niche specific problem. And then when you start digging into the problem, you'll realize, oh, probably like 5 other people are also interested in this problem. They've probably read a paper, they've probably written a paper, then you read them, then it kind of makes more sense because now there's a problem that you're bothered by, saying, ki, I've come till here, I've managed to identify, get some vision algorithm to identify my digits, but I can't do this next logical thing which I want to, which I want to. Nobody has told you to do it, but you've kind of like that problem, that burning problem exists in you. And that hopefully will lead you to write an SOP which makes a lot more sense, which actually it has information, which conveys information saying, this is what I'm an expert in. These are the kinds of problems that I've already dealt with. So I don't have to start from scratch. This is not like a training program in the high school sense where you're all blank slates and the teachers are like tasked and designed, this curriculum is designed to teach you things from scratch. Graduate level already expects you to have done enough homework, enough baggage that you get into it kind of like running. So that's the perspective. And of course, I'll probably want to stop here because I'll continue this in the next session as well, because these are all important questions and dialogues to be having. And unfortunately, nobody talks to us about this in a formal setting. Right? That's the part which kind of bothers me as well, saying, and it's not a secret. It's everybody knows this. Everybody who's in this game knows this. Everybody who's played this game long enough realizes it, but it's just not conveyed formally. And there's still this tight coupling of research, meaning PhD, meaning applications, meaning SOP, meaning LOR, meaning whatever. And in that entire chain, it kind of dilutes the very value of like enjoying that process, which some people may play that game and end up being good researchers. Hats off to them. They're playing that game. But statistically, in my experience, they'll likely not have a good experience. Likely. So it's the choice is yours as to which game to play. And that's what this course really wants to provide as a perspective, saying there are these perspectives, and some things seem just rationally more in line with the kind of journey that you'll likely face, and some perspectives are not. And you get to pick. The choice is completely yours. And we are all at the stage of our lives, like let's say early 20s, late 20s, whatever your stages are, where we slowly need to start exercising this autonomy as well. At some point, you need to put your foot down and say, no, this is right for me, because I know probably I have some perspectives on like what are the right things to be doing. And we can go through life, unfortunately, without ever exercising this autonomy, and that is unfortunate. But hopefully, at the end of this course, you also find that voice to exercise this autonomy, because research is all about like having a strong voice, an internal voice to say this idea may be worth pursuing, this idea may not be worth pursuing. So you need to, and it doesn't come on day one. It's a skill, it's a trainable skill. You need to train, you need to put in the hours and whatnot, but you need to consciously exercise it. You don't build like muscle mass without exercising. Likewise, you don't build this cerebral mass without exercising. So yeah, hopefully that's what you folks will end up doing by the end of this course. So I'll stop here. We've got, I think, officially 10 minutes. Happy to discuss, chat, but we'll pick this up tomorrow. And yeah, please let people know, especially, so here's my other claim. So especially if you have lots of friends who are in this race of applying to masters and PhDs, and like, this is also the time, I think this is November, so December, I think, is usually when the deadlines are. And if they're all like in this frenzy of like forwarding get them to sit through these modules, because uh, it's important, because it's so easy to have a bad experience, and it's just a waste of your time, your energy, your life, and likewise your mentor's time, energy, life. So it's good to take a cold sort of look at this, introspect, deliberate over it, and then make these decisions. So I'll stop here. So yeah, feel free to shout out any questions. I can't see the chat, unfortunately, but yeah, okay. Now I will probably. Akanksha has raised a hand. Yeah, go for it.
Professor, how much of like
Hey, by the way, okay, let me.
CS?
So
Okay.
I've seen this being doled out. I'm not a professor, so don't bother calling me a professor. It's unlikely I'll be a professor. So just call me Shashank or like whatever. So I'm still finishing up my PhD. So yeah, please, yeah, don't. It's very embarrassing if someone calls me a professor. So I'm not a professor. So yeah, go for it.
Okay,
I'm sorry
Shashank.
for like interrupting you, Akansha. Go for
No
it.
worries.
Yeah.
Thank you for the session.
Mhm.
How much of CS research is mathematical? Like, let's say you like research, you found some hard problems, you found this field, but it's so mathy. Like, you sit down to read a research paper, most of it is math. How much math, like, can you build that math competency up in your undergrad to follow through with it? And, like, does every field in CS necessarily have a lot of math to it?
Beautiful. I mean, I just love this question. Yeah, I'll address this, but I'll just take in questions now, and I'll write it down, and I can go one after the other. So if anyone else has any questions, feel free to. Now I can see the chat window, by the way. So go ahead and like type away, or like, just speak it out. I think that'll be convenient. So there was also a question about age. I see. Is it a very interesting after 45 years of age in a topic of interest outside funding opportunities? Okay. All right. So there's a question of age. So math. This is a great question. Many people before me have tried to address this question in different shapes and forms. The short answer is no. You don't have to be like a math ninja to be able to do good research in computer science. and I wouldn't call myself having trained myself in math formally. So do people in CSS do real analysis? No, 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 no. At least I haven't heard of folks doing things in real analysis. Probably theoretical CS, but Neil may be in better place. But I don't think real analysis is something. Why a bottom-up approach for where to start? Why not a top-down approach? So these are all jargon. So if you can tell me what you mean by top-down, it'll probably be more meaningful.
Yes, Shashank, actually, the bottom-up approach that I was thinking that I came up with, as you were explaining that.
Yeah, I get
Where
the
to
bottom-up
start.
thing. What is top-down?
Yeah.
What is top-down?
Top-down means why not to incorporate the research aspect in the curriculum itself? For example, last week I ended up with a course, 6 course on Edge AI, and the course was designed in such a nice way that you will, if you are taking that course seriously, you will be bound to come up with research gaps which are there in that particular aspect which you are studying, and you will be bound to, if you are thinking for doing research, you will get a path to come up with that where to start.
Fair enough. Point taken. So that's pretty much exactly what I had mentioned on the slide as well, saying if you've got access to courses which can get you started, that's probably the best place to get started.
But the problem in Indian is study system. I have been guiding to more than, I think, 2 dozens of master's thesis and this dissertations of
Sure.
from Indian universities.
Yeah,
So
yeah.
they teach only the concepts and never talk about this.
Yeah,
And
fair enough. Okay. I get your point. Point taken. So I'll address this sometime in module 3 and 4 as well. But I don't really see the distinction between top down and bottom up and stuff. So it's all the same thing, but I'll talk more about it as well. Fair enough. Going back to Akanksha's question, how much of it is math? No. So concretely, you don't have to be like a ninja to do good research in CS. Lots and lots of areas. In fact, most profs I know in programming languages in CS, in fact, I know one math prof who's like who would have been like a potential person that applied to in CMU, and she was like, and she did her undergrad in CS as well from like Arbonne University over here, and she was like, yeah, I hated it. I hated math, and I can't like get myself to like appreciating math. At least like some forms like linear algebra and stuff like that. But she is pretty much the top of her league in like systems software engineering program analysis research, and she's a faculty at CMU now. So there is this myth that yeah, math is like a very important thing, but there's nuance to it. There's also like a disclaimer over there saying at the end of the day, if you really have to express ideas which are like uh, pointed, which are like sharp, accurate ideas, math usually ends up becoming the language to express those ideas. So you can do a lot of things where saying you can come up with like a proposal saying, oh, you know what we should do, build a system which does this. But what academia generally also cares about is, are you sure the system does exactly what you claim it to do? So it could be like, let's say, even like content moderation, hate speech detection on like some platform, like let's say Twitter or Facebook or something. Sure, you can come up with like a hate speech detector of some sort or like whatever. But then there's usually there's a component of like formalness or formality or like there's a sense of rigor which math as a language helps communicate, and that's the true value of like math, and like that is why engineering is so math heavy, is because you really need to learn a new language to communicate your ideas. It's not enough for you to simply say, oh, let me have a system which does X. That translates concretely to an idea which you can express and probably solve for. Usually math provides those tools. But that said, it's not a necessary sort of skill to have. It's good to have. It is generally expected of you to have at least like undergrad level like math maturity. But that doesn't mean if you're not like strong at it, you can't do like decent research. If I look at my own experience, and I don't like doing these things as well, where I say, oh, if it has worked for me, it should work for you. There's like probably 100 things different in your life, which probably may have been different in my life. So there's no way to really do like a parity in saying that, oh, if it's worked for me, it's worked for you. But I do know that all the work that I published over here, including at some of the like uh, conferences, which like or like venues which these people consider as like important and whatnot, all the math that I've used there is things that I picked up after coming here, and it's not math that I couldn't have learned probably in high school. So if I given like 30 minutes, I could probably explain that math with the math that you already know. But when you read this paper, it may look dense because it's a different language, and you just need to get used to that language. So it's a I can't like ding you for like reading like a book in Spanish if you just don't understand Spanish, even though the idea may be like second standard, third grade sort of idea. So yeah, so that's a slightly longish answer to math, and we'll talk more about this in the last module where we've actually documented in module 6. Even if you go now to module 6, you'll find experiences from researchers in different areas of computer science. So that is one thing, unfortunately, which people don't even realize, saying that computer science is so broad. Like let's say someone saying machine learning AI is broad, that itself is so broad that it is fractured into like probably 100,000 like sub sort of problems and sub areas. But even CS is so big that there are these bigger chunks of like communities that you should probably be aware of. And we have attempted to get a researcher from each of these communities to reflect on their journey, how they got into it. So from someone like in language research, how did they get computational linguistics? How do they get into computational linguistics? Or someone in neuroscience, or someone in like computational social science, and so on. So it's the horizon is endless. Back to your statement, by its very definition, the playing field is like fairly large, and you can pretty much do whatever it is that you wish to do, and CS will kind of accommodate it given where we are as a field in 2022. So would you advise, I'll get to this problem from Satyam. Would you advise going into AI ML research without any concrete motivation in mind and just a general love for the topic? Is it too saturated? See, the way you frame these, so my grouse is in the way in which these statements are framed, which I'll keep driving over and again until you kind of I wear it out of you. So getting into saturated general love for the topic. So I'll again deconstruct this in like some painful detail. So hopefully by the end of this spiel over these 6 modules, you folks would have heard the same thing over and again, that it will kind of hopefully get internalized as to what is like a perspective that we should probably be thinking of. What does qualify as good research? Again, let's get into these details. So let me just write this down. Gaurav, good research. What is good research? There was like this bottom up, bottom down stuff. And what do so? I think I'm not sure who did ask this, Pranod, probably, and said, what if you don't have access to good courses where you don't get exposed, or like it's not taught well, or it's you don't find it to be like a good place to start research? There are some tips, but these are all like tips which anyone can come up with. It's just a lot more harder than, and it's just a lot of hard work. So I'll get to these in like probably the next module. So
So
I'm 2 minutes over. I'd like to stop here, not take questions. If you have more questions, please do follow up on Discord, and I'll hopefully see you tomorrow. If there was any other last minute logistics comments, we should probably get that out now.
Sorry, I just wanted to confirm if anybody was saying anything. Okay, Sunny is asking about readings. I think the course website has a ton of them.
Yeah,
So
yeah, yeah.
I think you could be complaining about not having enough to read. There's a bunch of references there, so I'll just drop a link to the website once again. And again, if you're not on Discord, please do join us there because that lets us keep the conversation going beyond the official timings of the course, so to speak. Yeah, Karan, no worries. I think the session is in fact recorded. I just shared the link with you, and these recordings will also be available from the website, so you should be able to find them quite easily. The Discord invite is also just coming up in a second, so do join us there, and that lets us keep the discussions between all of us going as well. I'm hoping we get a lot of peer advice in as well. Like Shashank has said, we're not pretending to be on a platform, and I think it's just good for everyone to share their experiences as well. We learn from each other just as much. So yeah, thank you everybody for joining. In terms of logistics, you may want to keep track of especially the announcements channel on Discord, or just watch out for updates from us in your inboxes. We'll probably email you pointers to a couple of more forms that you can fill, including super quick feedback form, so that'll help us calibrate our future sessions a little bit more, and other introspections. So I think that's going to come in before the next session. So we'd really appreciate it if you could take a look at that. And other than that, this is going to be the same time tomorrow, and it's going to be the same link. And we'll just look forward to seeing you there. And like I said, we keep the conversation going on Discord. Was there anything else, Shashank?
No, all good for me. One quick question is, Mr. Karthik, who's managing this, probably if you can get a copy of the chat, that'll be really helpful, because probably we can make an FAQ page at the end of this entire 6 modules and put it out on the webpage itself, which the students have asked. So if we can retain a copy of the chat, that'll be wonderful. Otherwise, I'm writing it down. I'll then have to find like a Sunday evening to actually type it all out.
Yeah, I think I've just done a low-key, low-tech copy paste
You
of the
copy
chat.
paste? I damn it! I was trying the copy paste, but like it was like so painful to get it done. Oh,
Right.
all right, it's happening now. Okay,
Okay. So
okay, wonderful.
right. So yeah, everyone, I think thanks to Shashank for doing this relatively early morning his time, and well, at least from my point of view, it's kind of early. But yeah, I think we're looking forward to catching up tomorrow with all of you. Thanks so much for joining, and we'll see you soon then. So just a request to Mr. Karthik to perhaps close out the live stream and WebEx session as well. Thanks, everyone.
Thank you so much. Bye bye.
Thank you for the session.
Very welcome. Please get your friends. So yeah,
Thank you.
thanks. Bye bye. Thanks.
Thank you.
Cheers, everyone.
I guess we can also just log off.
I think so. I've just sent a
Yeah,
message
sure.
to Mr. Karthik for closing the session out, and I think that should be
Sounds
good.
good.
All
Sounds
right.
good. Cool.
Thanks.
Thanks. Bye bye.